glad to be back. This time, more on the technology side of the discussion. So, Matthew gave a fantastic sneak peek of what goes behind the scenes of DigitalOcean. So, his talk was more on inside out. So, basically, what DigitalOcean does to keep their platform up and running, and how you actually get to enjoy the uptime and the availability. So, I'm going to take a different view. This is going to be more of an outside in. You as a customer or a consumer of DigitalOcean, what is that you can do to get better uptime and also some of the best practices for running production workloads in the cloud. Most of these are not just specific to DigitalOcean. They are applicable to almost any deployment that you run. But I'm going to take certain references, use cases, and scenarios of DigitalOcean because it's one of the plain and simple IaaS platform, and we can actually try implementing most of these best practices using DigitalOcean. So I'm going to start off with a scenario, right? I'm going to deploy a LAMP application on DigitalOcean, and then we'll dissect that and find out how we are going to turn that into more available, secure, and a reliable deployment. So I'm one of the startups. I have just a couple of guys with me, one designer, one developer, and we have implemented the local development system using Vagrant, like most of you. So here is my Vagrant file that is running LAMP stack, right? So this is currently available to me, which is running on the local host. If you carefully see, this is actually my local host, and this is called Cloud Shop. It's an e-commerce portal that my company is deploying, and we'll be going live on DigitalOcean. Currently, this runs on localhost. So the first goal is to get to the cloud, right? And the second goal is to make sure that we secure this, we implement certain best practices, and then start scaling the deployment, right? So this is a classic Linux, MySQL, Apache, and PHP app, right? How many of you are familiar with the LAMP stack and used it? Excellent. Okay, there we go. LAMP is still pretty popular. Okay, so here is my Vagrant, and here is my local host. So now I'm going to switch to DigitalOcean, okay? So I am one of the developer/operations guy, and I want to now go ahead and deploy. So what I do is I maintain my source code in GitHub. This is my private repo. We follow certain basic aspects, the primitives of storing our source code in GitHub and doing rolling upgrades and continuous integration. So that's my GitHub repo. Now I'm going to show you how I go live on cloud, right? So here we are. I know I asked this in the morning, but how many of you use DigitalOcean? That's less than 50%. So for rest of you, this is going to be a unique experience of seeing what it takes to spin up a VM and quickly go live. And I'm going to do a fun exercise. So I have a stopwatch on my machine. So let's actually go ahead and kickstart this stopwatch and really count how long it takes for me to go live on cloud, right? So 1, 2, 3, and I'm starting my stopwatch. Okay, so I'm going ahead with creating the droplet. So droplet is essentially the virtual machine that you can launch on DigitalOcean. So here is my Ubuntu box, and I choose 1404, which is my stable tested OS. So I choose my OS. Then I choose one of the cheapest boxes because I'm just staging this environment. So I choose a $5 a month size VM or a droplet. Of course, you could add block storage, but it hasn't come to Bangalore yet, so I'm not going to add the block storage. And then obviously I choose Bangalore as the region, and I enable private networking, which will give me enough access to other droplets that I'm going to deploy eventually. And then I use an SSH key that I already uploaded to my account. And I'm going to give this a name. Let's call this Cloud Shop and click on Create. That's it. So now it's going to take about 25 seconds to actually spin up the VM. And currently, we are at 1 minute. Let's see by when we are going to get this droplet in place, right? Honestly, I wouldn't take the risk of launching a VM in front of the audience if it is any other cloud, because it takes much longer. But I can very confidently attempt this exercise with DigitalOcean, because most of the times, the average is less than 40 seconds. 40 seconds, you not only have a droplet, there we go, even the SSHD daemon is up and running. So I'm going to grab this IP address, and now I'm going to switch to my terminal and SSH into my droplet. So there we go. Now, in less than 1.5 minutes, I am dropped right into the shell of my Ubuntu box that I launched. Excellent. So I now go ahead and install Git, because that's my code repo. So this is going to get me into the VM. So once this is done, I'm going to grab a slightly lengthy command where I'm actually doing a git clone of my repo. So now I'm pulling the Cloud Shop source code from my private GitHub repo into my staging environment. Okay, so this should take just a few seconds. And once this is done, I have a directory called Cloud Shop, and I have a shell script to basically configure my droplet. So for that, all I got to do is grab the IP address and pass it on to my installer script, because it's going to configure my Apache based on this host or the IP address, and that's it. Now I'm going to hit enter, and let's see where we are. We are 3 minutes 15 seconds since we started. So let's see how long does it take for us to really go live on cloud with this. I don't want to show you the matrix-like green screen, but this is an end-to-end walkthrough where I basically launch my first server and also set up everything that's required. So this is going to only take about a minute or so, right? So this would actually give me everything that I need. And once we are done with the basic setup, we'll go ahead and wire that up to a domain that I already blocked. So now MySQL is getting installed, PHP, Apache, followed by some dependencies. This is a very standard shell script. If you're curious, I'll be able to share the code repo as well. This is a pretty straightforward deployment. Okay, we are at 4 minutes, not bad, right? So my target is by 5 minutes we should be able to go live, right? This includes some other things like installing the dependencies and so on, but looks like we are on track. And this is just a 512 MB droplet. I'm not even using a high-end one. Excellent, so we are almost done. Okay, now I switch to the portal browser and just type my IP address, and there we go. And we are at 4 minutes 55 seconds, right? As I mentioned, I wouldn't take the risk of doing this demo on any other platform. I use many other cloud environments, but this is exactly what you get when you have an SSD-backed, high-speed, local data center. If you actually look at the latency, it is going to be single-digit millisecond latency. So now, that's not all. I come back to my droplet, and here I go to networking. And now what I'm going to do is quickly wire this up to a domain called cloudshop.in, which I already blocked, and associate that with my droplet that I just launched. So now the cloudshop.in domain is created. I switched to a different browser with a VPN because I don't want the cache results to come up. So now I'm going to type cloudshop.in, and if everything works, There we go. Right? From localhost to a full-fledged, all of you can actually visit cloud-shop.in, and this entire process took less than 5 minutes, which is amazing, right? But let's not get excited. Let's come back to this, and let's poke holes to this, right? There are a lot of issues. So this is exactly what I have done. One VM running database, running web, wired to a domain. Nothing fancy. But this is definitely not production ready, right? This is definitely not what I can expose to my customers. There are multiple issues with this. So I want to turn this into a production system. But what really defines a production system? Well, you define a production system when it is highly available, when your customers don't report errors or downtime. Your system is secure. Remember, we have been emphasizing on security since morning. Your system is scalable. It doesn't freeze when multiple users try to do the same thing. Your system is performant. It delivers consistently and efficiently, even under tremendous load conditions. And finally, your system is fault tolerant. What is the difference between availability and fault tolerant? They sound similar, they're almost synonymous, but there is a subtle difference between fault tolerance and availability. I'm going to show you that in a moment. So, where do we start? So now let's go ahead and turn this deployment into more secure, more available, and a production-ready deployment, right? First thing, strategies for security, right? DigitalOcean comes with a concept of private networks. So private networks, they give you two interfaces, two virtual NICs to your VM. One NIC is internal only, which is connected to the private network of DigitalOcean. Then there is one more NIC that is exposed to the outside world. When you are launching a MySQL server, you never need to expose that to the outside world. So you basically launch the VMs with private network, and then you go ahead and disable the public interface, public NIC. That's a very risky strategy. You might even lose connectivity or access to your droplet because you're basically cutting the branch on which you're sitting, right? That's pretty risky. But before you do that, you got to configure what is called as a jump box. So jump box is like your gateway into the cloud deployment. So jump box is like the gatekeeper, a watchman who will authorize and authenticate you, and once you pass the jump box, you have 100% access to rest of the droplets. So and the jump box itself is going to be very, very securely configured. It is basically configured with SSH with IP restrictions, which means you can only log in from a set of predefined IP addresses. So you cannot get to the SSH of any of the boxes from other IP addresses. So it is like a master key. So you open the gate with the master key, and then you have access to all the rooms. So you got to use this technique when you are deploying. And of course, a no-brainer, a thumb rule, and a very, very important capability is configuring firewall. Even if you cannot afford a very high-end firewall appliance or a firewall service, configure IP tables. So when you have a droplet or a VM with two NICs, for example, you never want a rogue service to hit MySQL directly, right? So MySQL, the data tier, is always accessed from your web tier or the app tier. So configure IP tables in such a way that only the traffic originated from your app server or web server is accepted by the database, and drop everything else. And IP tables are very, very intuitive. They are not simple, but once you master them, you can actually configure it the way you want. So configuring IP tables is like the basic thing that you can do to secure your deployment. So that is very, very important. I will come back and revisit the security aspect in a second. But that is about securing your deployment. Then comes the high availability. There is this philosophy of design for failure and nothing will fail, right? One important aspect of developing for cloud is that you got to be a pessimist, right? No one would ever tell you to be a pessimist. But as a cloud developer, you got to be a pessimist. You write a line of code, you deploy a VM, you configure a connection string and ask yourself, what happens if this fails? And always think that it is going to fail. And if it fails, how do you handle that? So everything is bound to fail. Nothing is going to be rock solid. Nothing is going to guarantee the uptime. Everything will fail. There is no service, no platform, no server, no laptop that would ever crash, right? So there are going to be failures. There are going to be disruptions. So you got to design for failure and survive those failures. So configure high availability for data, app, web tiers, right? And before you do that, you got to sign up for a reliable third-party DNS, right? So don't put all your eggs in the same basket. The DNS is going to be very, very important component of your deployment. It is going to resolve both the internal names and external names. Though many cloud providers expose DNS, what happens if the service is going down? So it's better to sign up for a third-party DNS that is outside of the cloud platform. And then use a technique called Cloud Init, which is very popular with Ubuntu, and now it is extended to cloud as user data to configure your droplets. So a lot of best practices, but let's take a look at it. So now we are getting back to the terminal, right? And let me show you how my production deployment looks like. This is my production deployment. It is secured, it's highly available, and it's a multi-tier architecture. Essentially, I have a load balancer that is running HA proxy. I have a web server. I have two web servers, actually. And I have two caching servers. And I have two database droplets. Now, there is a lot of redundancy built into this deployment. If web 1 fails, web 2 will take over. If cache 1 fails, cache 2 will take over. And DB1 and DB2 are configured with master-slave configuration. And at any point of time, I can promote my slave as a master with minimal downtime. I have also gone ahead and disabled the public interface on most of these boxes. And apart from that, I have signed up with something called DNS Made Easy, where I basically register the private IP addresses of my droplets. So if you notice, I have db1.int.cloudreadylabs.com. So I registered all the private IPs with this. So let's see some of this in action. Now let me gain access to my deployment. The first thing that I'm going to do is get into my jump box, right? So I SSH into the jump box. This is passwordless and pre-configured with restrictions only to my IP address. And now, when I actually ping web1.int.cloudreadylabs.com, it basically resolves to an IP address, right? So let's understand what this IP address is. But before that, I need to do a little bit of plumbing. So I'm going to basically enable the keyless SSH, passwordless SSH. And now I'm going to SSH into web1.internal.cloudreadylabs.com. So this DNS entry has a lot of benefits, right? More on that later. But now when I actually get into it, I am inside the web1 server. And when I actually do an if config, I get to see different network cards, right? So because I enabled private networking, I get eth0. This is basically the public interface. But at the same time, I also get ETH1 or ETH1, which is actually the IP address of the private interface. I left this because I wanted to show you that I have two NICs, and I'm going to selectively configure them. Now, what I do is I basically take this address, right, which is the internal IP, and register that with my DNS provider. So this is the internal IP through which I can resolve. If you try resolving this from your box, it won't, because this is a private IP. You can't even reach. But when I resolve this from my load balancer or the jump box, since it is on the private network, I gain access. So this is one of the best practices. Now, the private IP address can change occasionally, right? For example, my web server crashes, I bring up another web server, and this time I get a different IP address. What do I do? So I basically automate the process of updating the DNS A record for web 1. So what I do here is pretty straightforward. So there is actually a Perl script that looks something like this. Okay, it's better to show here. So I basically call my DNS API with the private IP address every time it is updated. So I basically put an @reboot entry in the cron tab. So if you look at the cron tab, there is an @reboot followed by a shell script where I call the setIP.shell script with the DNS name and the record name. And this happens every time my droplet reboots and comes up. So the moment it comes up, it registers itself as web1.int with the DNS. And after that, my load balancer doesn't even care whether it is the old droplet or the new droplet, because the DNS name resolves to the IP address that is more active, right? So this is the best way for us to manage the uptime within the private network, right? So that is one of the advantages. Now, in terms of using cloud init, this is pretty straightforward. Now, instead of writing an @reboot script in the cron tab, there is another mechanism for that, right? So what I actually can do is, when I am launching a droplet, I can enable something called user data, and I can pretty much copy and paste any shell script here. And this shell script will be executed just before the droplet comes up. So here, I will write 4 lines of script that will grab the private IP address, calls my DNS API by passing that along with the domain name, and every time my droplet comes up, it is up to date in terms of the DNS entry, right? This is one of the best practices. So don't miss out on user data and cloud init. This is a lifesaver. I can also run my setup script in this. For example, every web server that comes up has to run a specific stack. So I can use that shell script in user data, and every time I launch a web server, I know precisely that it's going to be configured. And this is what Tanmay was mentioning in the morning. How do you separate code from configuration? This is where my configuration will go, which is going to be separate from my code. My code doesn't even know where it runs. It's a vagrant or droplet or an EC2 instance, it doesn't matter. But this is where I separate the code from the configuration. Excellent. So those are the few techniques. So talking about best practices for cloud deployment is almost like doing a boot camp on good parenting. I can do it for 1 hour, I can do it for 1 day, or I can do it for 1 week, because parenting is such a vast topic, and there are so many aspects of parenting. So talking about best practices for cloud deployment is nothing less than talking about good parenting. There are so many aspects to it, but I have crystallized some of the most important aspects to bring them into this 45-minute session, right? So So we have seen this. We have launched redundancy across all the tiers. We are using a third-party DNS. We are using cloud init or at reboot scripts to make sure that we do pre-boot config. So this will give us some kind of high availability, right? And I've also configured IP tables. I don't want to really go into the weeds and show you the various configurations of IP tables. It's very overwhelming, but you get an idea. Strategies for scalability, right? So scale is very, very important. As we mentioned earlier, follow this principle. It has to work well, it has to work fast, and it has to scale, right? So that's how you keep iterating. So when it comes to scalability, always configure a load balancer, both internal and external. External will keep your users happy because it can route the traffic across your front-end servers. You need an internal load balancer when you are using redundant servers for cache, for databases, for file systems. File system may not be the good idea, but any TCP, UDP, internal communication that you have, you may have to use an internal load balancer, right? You have to enable caching, right? This is a very simple technique. Most of the LAMP applications respect caching. For example, go to php.ini and replace session handlers from file to memcache. Very simple. That will be a lifesaver because you are moving the sessions away from the web server to a centralized cache. And even if the web server crashes, your user's shopping cart won't be gone. When he comes back and when the web server is back, because the session has been pushed into a centralized cache, the shopping cart is survived, right? So is rescued. So don't miss out on configuring caching layers. Implement autoscale, right? So autoscale is not a feature of every cloud platform. Autoscale must be credited to AWS because EC2 was the first service that actually introduced the concept of elasticity. But it is not very difficult to configure. Basically, it's a rules engine that says if the average load of my web servers hits a specific threshold, then call the API or the CLI to launch one more with all the automation inbuilt. So Matthew was talking quite a bit about logging and metrics. If you are cautious, if you are monitoring your fleet of servers closely, implementing this is not actually a big deal, right? And I have Madan here who runs Acton Cloud, and he built a rules engine that will bring autoscale to DigitalOcean. So there are ecosystem players who are bringing in those capabilities. Either do it yourself or tap into services from Acton Cloud or others, right? So you could actually implement. So this is not something that cannot be achieved just because the cloud provider is not offering you. So let's actually see this in action, right? I want to show you a very quick demo. So I'm now accessing my production ready system. Okay, this is not cloudshop.in. This is still on an IP address, right? Or actually, let me access that. So this is called shop.cloudreadylabs.com. So this is my final go-to URL, right? So I'm going to go ahead and log in. So I will log in with my username and password. All right, everything looks good. And if you actually see, it says you are logged in as Janakiram. This is fine. Now, I'm going to come to my jump box and do something very drastic, right? So what I'm going to do is stop my Apache servers. So I'm stopping my, oops, this is Apache 2 on web 1. Okay, so now I'm stopping Apache on my web server. Okay, I will come back, do a refresh, nothing changes. This is pretty good. I come back and then I also go ahead and crash my second web server. So Apache is dead on both. And when I do a refresh, it gets stuck, right? My load balancer is unable to forward. I see this. Most of your users would also see that. Now, because I'm implementing caching, guess what happens? So I'm going to bring up both my servers. okay? Hopefully, when I do a refresh, my session is still maintained. I am still logged in. If you don't implement centralized caching and move sessions to it, this would have been a disaster. What if I added an LCD TV worth about $1 lakh, and I was about to click on checkout, and the website crashed, and I lost my shopping cart? The next thing that I do is switch to a competitive site, and even don't mind paying more because I had a very bad experience with this. So again, caching is super critical for production systems, both for your session, your product catalogs, and wherever you need to deal with this state. Strategies for performance. I can't emphasize more on this. Monitor key system metrics. I created this slide before I heard Matthew's presentation, right? And if you see, DigitalOcean is managing a massive scale that is spread across the globe. And how do they deliver on their uptime and keep track of the resources? They are dealing with a meta problem. We are talking about your deployment of 6, maybe 8 droplets. But think of DigitalOcean, 13 data centers, 8 geographies, millions of droplets, SLAs, and mission critical systems. And they need to maintain the underlying infrastructure without ever disrupting anything. It's almost like refueling an aircraft while it is in flight, right? It is so challenging. Have you seen Air Force One? It's very similar to that. So DigitalOcean has to scale up their infrastructure while the customers are still using it. It's on the fly, very, very challenging. The only way that they can do is to have a very strong, almost a bulletproof system based on the system metrics and logging, which will give them insights into the infrastructure. The same thing is applicable to you, even at a smaller scale, right? Don't avoid tracking the metrics. There are many open source agents and infrastructures available for you. For example, Nagios, very, very popular. Nagios also complements one more open source product called OpsWorks, right? OpsView. We used it extensively for configuring, monitoring for our customers. So a combination of Nagios and OpsView would give you a very good insight into the system. Configure logging. Use FluentD, right, or CollectD, or any of the open source logging mechanisms, or sign up for APM things like New Relic or Logly, right? But make sure that you're aggregating the logs. They tell a story. They tell you what your customers are doing, what the problem is with your deployment, and they provide you very, very useful insights. And a no-brainer, scale up droplets when required. In DigitalOcean, it is possible to scale up an existing droplet. There will be a minimal downtime, but you can move from 512 MB to 1 GB droplet in a few seconds. So it's a pretty fast scale up. And increase swap memory if you are running Linux on your VMs. And of course, DigitalOcean only supports Linux distribution, so this is pretty much applicable. So configure enough swap memory. Resize block storage as required, right? So again, you can resize your block storage after you have gone live. This will make sure that you have enough room for growth. Again, configure a caching tier for the performance, not just for availability, right? Memcache, Redis, XD for configuration caching. You can do a lot of useful things by moving your configuration to the cache tier. And deploy a reverse proxy, right? For example, deploying a Varnish if you are a content-heavy portal, or even running a simple Nginx as a reverse proxy or a HA proxy would make a ton of difference to the performance. So then it comes to strategies for fault tolerance, right? So fault tolerance, what is the difference between fault tolerance and high availability? They sound synonymous. What does it mean? High availability has some expected or perceived downtime, but you'll always get back to where it was. But fault tolerance is becoming very, very tolerant to disruptions and downtimes with absolute uptime of both infrastructure and applications, right? Fault tolerance is typically factored at two different layers, at the infrastructure layer and at the application layer. Infrastructure layer, you have very little control because you are on a virtual platform. But application layer, if something goes wrong, you got to take the blame because you had every opportunity to make that fault tolerant. So what can you do when it comes to fault tolerance? Attach floating IPs. So there is a level of redirection, right? I'll show you a demo right after this. Always use block storage for stateful droplets. Both block storage and floating IPs are lifesavers. There is a droplet, there is a floating IP, and there is a domain. So you basically create a loosely coupled association across these three entities. Your domain points to a floating IP, and your floating IP is assigned to a droplet. Later on, when your production droplet crashes, you bring up another droplet and attach that to the floating IP. And because the floating IP is mapped to the domain, everything is good, right? So it's a very, very quick mechanism to bring up another healthy server and replace a faulty one, right? So never miss out on attaching a floating IP to your customer-facing, public-facing droplet. It might be costing you a few cents here and there, but it is very, very critical. Same thing with block storage. Block storage is a fairly new service added to DigitalOcean. It is, as PJ said in the morning, it is almost like a USB flash drive that you can plug into your droplet. My recommendation is never ever go live without attaching block storage to your database servers. If you're running MySQL, Postgres, Mongo, any of the persistent data stores, the moment you have your architecture in place, the moment you're launching a droplet, you attach a block storage and mount your database log files and transaction files on the block storage and not on the ephemeral storage that comes with the droplet, because if the droplet crashes, you lose your data. The moment you mount a block storage and point your transactions and logs and the data files to block storage, nothing really happens even when the droplet crashes, because you could technically unplug the block storage, plug it into another MySQL instance, boot the system, boom, you have exactly the same transactions and same data available to you. So both floating IP and block storage decouple your systems from the mission critical backend, right? So web server, floating IP, database server, block storage. This combination will make your systems more fault tolerant. And of course, schedule regular backups, which is just a one-click away with DigitalOcean. So the moment you launch a droplet, you configure and schedule a backup. But don't forget to perform regular fire drills to test the backups. In majority of the scenarios, what we discovered is when the real disaster happens, that's when the backups are tried to get restored. And then we realize that the restore process is failing, and there is some problem that is stopping us from restoring the most recent data set. That is the problem of not doing fire drills and testing your backup restore workflow. This is very, very important. So backups need to be constantly tested. So you need to have regular periodic fire drills where you take the backup and try it on a staging environment or in another environment to make sure that you have a great workflow and a consistent backup restore process. And of course, you can enable snapshots, which are point-in-time backups of your droplets, and you can create new images from those snapshots, and you can relaunch droplets. This is another mechanism that you can use to create fault-tolerant systems. So this is how the production deployment would look like. There is a load balancer with the public interface enabled, connected to your floating IP. There is Web 1 and Web 2 We disabled the public interface on that. They are secure. You cannot hit the web server directly. You have to go via the load balancer, and an IP table configuration will prevent you from accessing anything on the internal deployment. You have to go through the load balancer. The cache is running memcache. It is basically managing both the sessions as well as a product catalog. And we have a memcache replication set where we are creating a HA replica for memcache. And we configured MySQL in a master-slave configuration. The slave can also act as a read replica, which means you can offload some burden from the master server by redirecting some read queries only to DB2. And in case the master, which is DB1, crashes, you can run one script that will promote DB2 to DB1 by running some internal MySQL commands as well as changing the DNS endpoint, so the app doesn't even know that you just promoted a slave to your master. And then from the snapshots, you bring up another droplet, and that becomes your new slave, and then the replication will kick in, right? So all this can be pretty much automated with very, very minimal downtime. And of course, this is powered by an external DNS. So we have the domain name registered with the external DNS. The external DNS is wired through the floating IP, and then we have the internal deployment, right? So I want to show you a couple of more demos to show you load balancer in action, and then to show you the fault tolerance of this system. So what I'm going to do is, currently every time you hit, you're seeing the page, this is fantastic, but what is the guarantee that my load balancer is in action? So what I'm going to do is just replace the logo on my web server. So I'm going to replace the logo on web 1 with a different one, and same thing with my second box. Don't worry if you're unable to follow these commands, they are a little cryptic, but the idea is this. So now, when I actually do a refresh, I get to see a number next to the logo, and that is an indication that our load balancer is doing its job. Okay, so this is now a slightly performant system because we are able to route the traffic across multiple droplets. Let's test the fault tolerance of this, right? So I go back, and now I'm going to basically kill Apache on one of the servers again, right? So I'm killing Apache on 1. Now, at least you should be able to see 404 or 503 occasionally, but let's see what happens. The good thing is 100% of the traffic is going to my second server because the first server is dead. And the customers don't even know that. But my logging system has alerted me that the Apache daemon is dead for last 5 minutes. But the customers would never come to know about it. It just works, right? Why does this happen? Because I configured HA proxy with certain rules that basically shows the health checks and how I am managing this. I'm not sure if this is visible, but if you see, I have configured HA proxy for upstream URLs pointing to my web 1 and web 2 with enough checks. So this is making sure that my website is alive even when one of the web servers is dead, right? So that's the beauty of it. So let's bring this back, and we should be back in shape. So now Apache 1 comes back, and there we go. And the best thing is, I'm still logged in. Web server 1 didn't kick me out because my session is preserved outside of the web server, right? Again, by no means this is the most comprehensive guide or a checklist or a standards operational procedure for running production workloads, but my whole idea was to give you the thumb rules and the baseline configuration without which you cannot even go live. So I want to summarize a few things. Assume failure can happen and design accordingly. When you are a cloud customer, you got to be pessimistic about the application. Always think, what happens if this fails? Decompose the application to avoid single point of failure. This is very critical. Never run in monolithic mode. I have personally seen some very well-known e-commerce portals in India. When they started, they ran everything in one VM for a long, long time. And we used to plead them to let us separate the database and at least run that in a different VM. But no, they were very, very cost sensitive, and they ran everything in one VM. Very scary. So always draw lines wherever possible. Break down your application into multiple layers. And it doesn't mean you have to go back to the whiteboard and architect your application as microservices. Simple things like separating databases, cache, web servers, load balancers, and firewalls, and having clarity on how you're going to decompose and connect all of them will make a huge difference. Reboot the VM from the OS and not the control panel. This is one of the classic mistakes that DigitalOcean customers do. You get tempted to click on power off button or power recycle button from the portal. Avoid that. That's going to corrupt your file system and sometimes makes it irrecoverable. It will actually lose everything. So instead, get into the OS and do a graceful shutdown. Deploy a load balancer, no brainer. It's very, very critical, and it's basic hygiene. Design and test a backup recovery strategy. Can't emphasize enough on this. Configure monitoring for your deployment, right? So again, I am right on time, 3:45, and I'm done. So that was a sneak peek of what you can do with DigitalOcean when you're running production deployments. 90% of what I shared with you is applicable to any deployment, not necessarily DigitalOcean, not necessarily cloud, right? So do we have time for questions?
Can we take 2 questions?
Sure.
Yeah. Just in the interest of time, if you have any questions, raise your hand and we'll get a mic across to you. Okay, we have exactly 2 questions. Okay.
Yeah, the instruction about not rebooting from the console or from the UI, does that apply to Azure and other as well? What's the logic behind that, if you could please explain?
So okay, so normally what happens is, when you are using the console and terminating an instance, you actually send an ACPI power off instruction to the machine. ACPI power off is as good as walking to the machine and hitting the power off button. That is not a graceful shutdown, right? When you are logging in and when you issue a shutdown command or a reboot command, you are basically asking the OS to do the recycling in a graceful form, right? So that protects the entire consistency of your system. This one? Oh, I think they froze the frame. Yeah. Sure, I'm going to put it up on SlideShare and share the link. And by the way, another plug, I'm going to do 2 elaborate webinars pretty much highlighting this. So because you have registered, you would be receiving an update. Next week, we have a webinar on 19th, where I talk about how to create available applications and deploy them on DigitalOcean. And the webinar in November primarily focuses on high availability and zooming on to some of these aspects. So do sign up for those if you need additional information and additional insights. One question, yes.
So where do you manage the load balancer? Because if you're using load balancer to distribute traffic,
yes.
Do you do it in DigitalOcean itself or somewhere outside?
First of all, thanks. Thanks for keeping an eye on what is going on, and thanks for being attentive. So if you have carefully noticed, my deployment had one single point of failure in the form of load balancer. What happens if load balancer crashes, right? So that's exactly why I use a third-party DNS. So in DNS Made Easy, dynamic DNS, and other parameters, you actually can do a DNS failover, right? So with DNS failover, I basically have 2 load balancers with 2 different floating IPs registered to the DNS. And your domain is routed across these 2 load balancers, provided they are responding with HTTP 200. The moment one load balancer dies and it is not responding, your DNS service will stop sending traffic to that. So this is like who will watch the gatekeeper, right? So you are creating a meta service to watch the load balancers from the outside world. That's the reason why I use a DNS failover beyond the realm of the cloud. That's where you actually get HA for load balancer. Cool.
All right. Thank you, Janakiram. Not too many, yeah.
It is very hard to put a number. It is extremely hard, but it is. For example, see, I can do a back of the envelope math, right? I'm running 8 droplets.
How many droplets we need to create and okay?
See, this setup needs almost 7 to 8,
Okay.
right, with jump box. And I didn't add monitoring. Typically what I do is I add monitoring to jump box, so it doubles up as a monitoring server as well as the gatekeeper. 7 to 8 is a safe count.
Okay. Thank you.
Right.
Okay.
Cool.
Thank you, Janakiram.
Thank you.
Not too many speakers would want to do a live demo. You've done a live demo, a command line demo, as well as with a timer. So
Right.
hats off to you. Can we have a huge round of applause for Janakiram?
Thank you.
At DigitalOcean, we really appreciate you taking the time and being a part of DigitalOcean TIDE.
My
so
pleasure.
thank you very much. Thank you.
Thanks so much, Paul.
Thank you, sir.